Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, so uh, today we are going to move to the next chapter, which is we're still in chapter 2, but the second part of chapter 2, which is the other types of list abstract data type or the other types of data structure. Okay, since we know that the first types of list that we have learned is array list, right? So we have the second type of list, which is a linked list. Okay, linked list. Okay. So the array list, this is all about array list. Okay, this one. In order to avoid the linear cost of insertion and deletion, we need to ensure that the list is not stored contiguously. Okay, since we implemented the array list contiguously using indexes, right? Okay, we keep the data in indexes, and the indexes are contiguously, okay, one after another. Okay, so the linked list is implemented using nodes linked to each other, which are not necessarily adjacent in memory. Okay, so to avoid the data stored contiguously, data kita nak simpan tu dekat-dekat, so we implemented linked list, which is we can store data adjacent, jauh daripada satu sama lain dalam memori tu lah. Okay, so kita simpan dia menggunakan node. Each node contains a previous node link. Okay, next node link and value which contain the actual data. So kita tengok apa ada dalam node itself. Okay, so kita nak compare dengan array list. Array list tu kita menggunakan indexes. Okay, while this linked list is using node. Okay, this is the view or the design of our node. What is the content of our node? Okay, every node in a linked list has two components. Okay, secara umumnya, so our linked list has two components. Okay, one is, you can see here, okay, the one to store the relevant information, means that our actual data. Another part in our node is to store address to the next node in the list. Okay, so kat sini kita simpan our actual data. Let's say you have the information of our student, so okay, student name, student address, student CGPA, student apa-apa semua kita simpan kat sini. So this part is to keep, okay, to store dia punya address untuk next node. Okay, sebab apa kita kena simpan address to the next node? Kalau array list, we know that the next node should be contiguously atau bersebelahan dengan the current node, tetapi not to linked list. Linked list itself, the next node can be stored or can be located in anywhere in the computer memory. So how we can know that the next node here and there? So we need to keep the address of the next node itself. Okay, address of the first node in the list stored in separate location called the head or first. Okay, so normally the first node in the link, okay, we keep the address of the first node tu dekat head ataupun first lah. Okay, this one is the structure of our node in our computer memory. So we have a head. Apa yang ada dalam head ni? Head ini akan simpan address for the first node ni. Okay, this one is our node, next node, and the last node will be pointed to null. Okay, when new data is inserted, a node is inserted and the link of the surrounding are updated accordingly. Okay, so once we inserted a new node in our linked list. Okay, so as I mentioned just now, the node itself can be located anywhere in the memory, but how we can know that that one is our second node that we just inserted? Okay, so what we need to do is we need to update the address of the current node. Okay, so to make sure that we can point it to the our new node. Okay. Okay, same goes here once we remove the node. Okay, bila kita remove pun sama, dia akan update. You can remove any node. What we need to do is we need to update the link. Okay, so macam mana dia berfungsi? If previously satu node ni address dia point to the next node. So bila kita update, okay, so we do not need to point to the next nodes anymore. Kita point ke node yang lain. So automatically node yang berkenaan will be deleted and dia akan pergi ke garbage collection lah. Okay. So this as well, key strength and also weakness. Okay. So one of the dia punya strength is fast manipulation. Adding and removing new data anywhere in the list is instantaneous. Okay, change to link and you have a new value anywhere that you want it. Means that dia lebih cepat lah. Okay. No random access. Okay, even though, okay, the get, okay, integer is still there. It now just iterates the list until it reaches the index you specify. Okay, linked list implement extended abilities to the normal list interface, which allow it to add and remove element from its beginning and end. Okay, so you nak add ke, you nak remove ke, you boleh remove daripada depan ataupun daripada belakang or at the end of the linked list. Okay, this makes the linked list perfect for queue and stack purposes. Okay, I want to highlight here, you need to really understand this linked list chapter because this linked list will be implemented in queue data structure and also in stack data structure. Okay, so lepas ni bila kita nak continue with queue, it also implements linked list punya implementation, which is we are using node to implement queue. Same goes once we want to implement stack pun dia akan guna node juga. Sebab apa? Because we are using linked list.